Finally, to us all, and you're on to Mango with Jarvis. Today we'll be taking an aspect of maths, arithmetic, and under arithmetic, we'll be looking at something called directed numbers and BODMAS. Essentially, the concept of BODMAS is best appreciated by looking at directed numbers. We had answered this question before now. What are directed numbers? Directed numbers are first whole numbers that can be positive or can be negative. So another name for directed numbers, it will be what is called integers. Means numbers that can either be what? Positive or negative, but essentially they are what? Whole numbers. So we're going to use the concept of directed numbers to explain the matter of BODMAS. So let's get into the work of today. And as usual, our textbook of reference is the New General Essential Mathematics for grade 10, which we call over here SS1. And this is one book I recommend because it's so incisive. It's a very good book if you want to do self-learning, and you have lots of examples to tackle. So let's get down to the work of today, considering directed numbers and BODMAS. So let's go. When we mention BODMAS, what comes to your heart? BODMAS talks essentially about steps you need to take, what to look out for when you solve problems. And I'll start with that before I go into saying how BODMAS links to directed numbers. Now, BOD. It means if given any mathematical problem, these are the steps you need to take. These are the considerations you must make in such a problem. Now look at this. This says what? Handle the bracket first, if any. O say take care of the off, if any. This says go then do division, if any. M says multiply. If any. A says take care of the addition. And finally, take care of the what? Subtraction. As I begin to solve problems, I'm going to show you some twists to this rule. Some twists. There are twists to the rules, and it takes you having a bit of higher insight to see that these are just guides for you. You will see some things will materialize as you solve, but I won't talk about them now. I want us to handle problems, see them, and then deal with them. So we come to directed numbers. So we said that when we talk about directed numbers, we essentially are talking about what? Whole numbers. Okay, so when we're talking about directed numbers, what essentially are we talking about? We're essentially talking about whole numbers that are what? Positive, and we have also that are what? Negative. And we said that whole numbers are formed from 0, 1, 2, 3, 4, 5, 6, 7, 8, and what? 9. But when we talk about integers, These numbers can be what? Positive or what? Negative. 0 stands alone, and then positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 4, positive or negative 5, positive or negative 6, positive or negative 7, positive or negative 8, positive or negative 9. So you have an array of about 19 digits to play with. And then anyhow you combine them, you're going to have numbers that are positives and numbers that are also what? Negative. All right. The earliest idea that introduced number, what you may call directed numbers, is what is called the number line. And it's interesting to note that although this is not the class for such, because at grade 10, I'm only trying to just give a little bit of the foundation on that, and then I'll build on it. But I will also try to do videos on this matter. I also have some videos on this too. I'll try to check my archives and make these videos available to us. Now, the concept of directed numbers is that you are starting with 0, and this concept is called your number line. So this is what is called the number line. That if I move towards my right, what I'm going to have will be what? Positive values. And when I move towards my left, I'm going to have what is called negative values. So I'm going to have this as 1, 2, 3, 4, 5, 6, 7. Working with the mindset that my number line takes into consideration whole numbers. Negative 1, negative 4, negative 5, negative 6, and negative 7. All right, so this is my number line. What do you use the number line for? You can use number line to add, you can use number line to subtract, you can even use number line to multiply. And we're going to just try all of that on the board and see how that works. And let's assume, because our using this will help us draw some very relevant conclusions. Now, I'm going to keep this as reference for what I want to do. Let's assume I have what's called I have 1 plus, okay, let's just say number 1 plus 3. 1 plus 3 will mean start from 1, move 3 steps to your right. Plus means what? Move to your right. So I'll start from 1, I move 3 steps. 1, 2, 3. Where I stop will be the answer. So 1 plus 3 becomes 4. Is that not? But what about if I now say 1 minus 3? It means start from 1, move 3 steps backwards. The minus means go to your left. So to use your number line, you must understand that y plus will mean go to your right, minus will mean go to your left. So we go from here, 1, 2, and 3. I see that 1, 2, 3. So what's the answer? Negative 2. And that's correct, because if I have 1 naira and I have to give out 3 naira, I'll be able to give out 1 naira without stress, and I'll have to look for what? 2 naira. That's the understanding of that problem. Right. So this is our number line, and this is what that is. Now, that's doing subtraction and what? Doing what? Addition. Okay, so we will now go ahead to try to look at, we'll now go ahead to try to solve problems, and as we solve problems, we'll try to see how some of them work in line with what? Your knowledge of BODMAS. Okay, so to kickstart our work, we will try to look at some golden rules. So let's look at some golden rules when it comes to addition and subtraction and even multiplication. Now let's look at this. Let's start with addition. So remember, we're considering directed numbers, as a model to look at certain general rules in maths. Now, if I have plus and I add it to, if I have a positive number and I'm adding it to another positive number, what would the answer be? If I have a positive number and I'm adding it to a negative number, what would the answer be? If I have if I have a negative number first and I'm adding it to a positive number, what would the answer be? If I have a negative number and I'm adding it to a negative number, what would the answer be? These are the first considerations for addition. Now let's go to subtraction. We will explain them, and because this is so important to our work. Now for subtraction, I have a positive number and I'm removing another positive number from it. What would I get? I have a positive number and I'm removing it from a negative number. What would be my answer? I have a negative number and I'm adding and I'm subtracting it from a positive number. What will I get? And then I have a negative number and I'm subtracting it from, or rather I have a negative number, I'm subtracting from a negative number. What do I get? So let's look at what the outcome of this will look like. All right. Okay. Very interesting. These two things you see here and two to come are the most essential aspect of how quickly you will process the problem in mathematics. I come again. These two and two yet to come are the most fundamental ideas that will drive how well you can process problems in mathematics. And I want to beg you to take out time to practice this and understand the logic. To explain these ideas, we'll go with what I call the example approach. We will present the matter and then we would expect that you would use an example to create a general case. So here we go. Now look at it. We're going to addition now. And the first one I'm considering is plus. I've used this bracket to show that these are positive numbers. Positive plus positive. Once in a while, I make this error. With numbers are essentially positive or negative. And this plus you're seeing here is an operator. Plus is an operator. Why these signs you're seeing here are essentially what? Telling you the type of numbers you have. So, pardon me if I make one or two of such mistakes, and let's try to do those things that are right. Okay, now, what would the outcome be? We go by taking an example. 2 plus 3 will give me what? 5. Because 2 plus 3 is giving me 5, I will say, okay, then that's 1. Then what if I now take 3 plus 2? Also give me what? 5. So we say that this one must give me a positive. If the two numbers are positive and you add them, the answer must be what? A positive. Now let's numbers now we can put them in perspective. Number 2. If you have a positive number and you're adding it to a negative number, what would the answer be? Let's think. We take scenarios again. Now, there's a case where you have 2 plus negative 3. This will mean 2 minus 3. And because 3, the negative, is bigger than the positive, your answer will be what? Negative 1. Now, does it mean when you do this you get negative? That's not true. We will now check. If we swap the numbers, we will still get the same thing. Now look at this 2, 3 rather, plus negative 2. This will mean 3 minus 2. And that will give us what? 1. Because in this case, the positive is bigger than the what? Negative. So our answer becomes what? Plus 1. So we say that in this case, the answer can be positive or can be what? Negative, depending on which number is bigger. So if you are subtracting two numbers, or you're adding a positive number to a negative number, if the negative is bigger, the answer will be negative. But if the negative is smaller, the answer will surely be what? A positive. Right? So that settled. We'll then come to the next case. What about if it's negative first? And I'm adding it to a positive. What would it be? Think. So what we'll do is to take the same numbers, negative 2 plus 3. What would that give me? That will give me what? 1. What if I have negative 3 plus 2? What does that give me? That will give me what? Negative 1. So what's the conclusion? This will be what? Negative plus positive or what? Negative. So the conclusion here is this. If I'm adding two numbers, looking at 3 and 4, if I'm adding two numbers together, the answer I will get will be a function of which is bigger. So if the negative is bigger, my answer will be negative. If the negative is smaller, my answer will be what? Positive. Right, so go to number 4. And in number 4, you have negative plus negative. Here again, we check. If I have negative 2 plus negative 3, this is what? Going to be what? Negative 5. Because both numbers are negative. So essentially what you are doing is that you are adding. If I have negative 3 plus negative 2, the answer becomes also negative 5. So the answer must be negative. So what is the conclusion you can draw from here? Anytime you're adding two negative numbers, the answer will be negative. Meaning that for every time you add negative numbers, you are pulling yourself more into negative. Now let's use a practical example. If you collected 2 apples from a friend and you go to collect another 3 apples from another friend, what you have to give back will be 5. Because what you collected will be 3 plus 5. And you have to bear the brunt of returning 5 apples back. Right? So that's for the concept of addition. Give us some time to process that and then we'll move ahead. All right, so let's continue. Now we go to subtraction. Now we'll take the first case. We have a positive number minus another positive number. What would it be? We still go with our example, but maybe this time around I'll use 2 different numbers. I'll use let me use 3 minus 4. You discover that 4 is bigger than what? 3. I have 3 naira, but I need to give out 4. I will need 1 naira extra. So that means the answer will be what? Negative. So let's swap. What you notice, the answer will be positive because the positive is bigger than the negative. So we discover that for this to be plus or minus, positive or negative. So if you're doing subtraction, and you have 2 numbers, if the number being you're taking another number from, the number you're taking another number from is positive, is bigger, we expect the answer to be positive. Or put in a language that you can better appreciate. If I say 4 minus 3, if the first number is bigger than the second number, we expect that the answer will be positive. But if the first number is smaller than the second number, we expect that the answer will be what? Negative. That's something you really need to take note of as we solve problems in math. Right? So that clears that. So the answer is undecided whether the positive or what negative. So number 2, we have positive minus negative. So what happens? So I'll use my 3 and 4 again. 3 minus of 3 minus negative 4. This will mean what? Negative times negative will give you positive, and that will give you 7. Now I don't know how you were taught before now. But let's also try to really analyze this. I have three things, and somebody is giving back what he owed me. What do I have? Now, in this context, when you say 3 minus, it means I have something and I'm giving out. But here, it means I have 3, and somebody is giving back to me what originally had given to me. What will the answer be? The answer will be what? 3 plus 4 means you are adding. And that will be what? 7. And I want you to take note of this. That's the reason why when you have negative, it becomes what? Positive. I have, and somebody is giving back to me what he owed me. All right. So this one means giving back what is owed you. So this will not be 4 minus negative 3. The outcome will still be 4 plus 3, and that will be what? 7. So the answer must be positive. The answer must be what? Positive. Must essentially be what? Positive. So take note of this condition. Now the next one you have is one that says I have negative first, and I'm going to remove positive from it. What would the answer be? So we check the conditions again. Say 3, negative 3 minus 4. This would mean add the negatives. That's what it means. I'm owing 3. And from that 3 I'm owing, I'm asked to remove 4. How many will I be owing? I'll be owing 7. I didn't have 3. And from the 3 I don't have, I'm now told, okay, let me give a very practical scenario. You have 2 children. The first one had school fees. You need to pay the school. 3,000 for instance. I have another child, you need to pay the school 4,000. So how much are you owing? Because remember that negative suggests that you are owing, you are indebted. So 3 plus 4 will be what? 7. So in this case, the answer will be negative 7. So what about if I now switch? It's still the same effect, it will be negative 7. So in this setup, the answer must be negative. So if I don't have, and I'm forced to make another payment, I will owe more. Do you get it? So it doesn't matter whether the first one was big or small. No, you're not bringing anything in. You're giving out. So that's what this explanation is talking about. Now let's go to the final one, which says negative minus negative. What would this answer? Let's think about it. So let's start with 3, negative 3 minus negative 4. The interpretation of this is negative 3 plus what? 4, and that is what? 1. Because the positive is greater than the negative. You will begin to see that there's also a relationship here. There's a relationship. That's why you really need to study this and this carefully. Because you discover that there's a relationship. At some point in time, you need to borrow an idea from here to be able to handle this one here. Right? So that's taken care of. Now, what about if I have this? What does that give me? That will give me negative 4 plus 3. And what will the answer look like? The answer will be what? Negative 1. Why? Because the negative is greater than the positive. That's for what? Subtraction. So, what happens in multiplication? What do you see? This one is quite straightforward because in this setup, we don't need to know whether it is. The rule here is quite straightforward. So, if I say plus times plus, my answer will be plus. I don't need to show any example here. Or maybe just write one so that you see what's happening. 2 times 2 will give me what? 4. This is a positive number, this is a positive number, and the answer will be what? positive. So now let's leave the loss times negative. My answer will be what? Negative. 2 times negative 2 will give me negative 4. Quite general too. Now, let's assume the negative comes first. It will still be negative. The thing here is that negative is so powerful when you're multiplying numbers. Negative is so powerful when you're multiplying numbers. Negative has a dominant effect over positive numbers. So this will be negative 2 times 2, and that will be negative 4. Let's see what happens to D. I have negative times negative. Now, when negative meets with itself, especially in the realm of multiplication, what happens is that there's a new reality, and that is what? Positive. When negative encounters itself, the answer must be what? Positive. So that's for, let's take an example, negative 2 times negative 2 is equal to what? Positive. Let me drop something that would form a very interesting knowledge for us in the future. That's why you say negative. If the answer is positive, it means that you either say negative times negative, or you're saying what? Positive times what? Positive. The answer must be what? Positive. But if you say negative times positive, now look at the tops, and you have what? Positive times negative. So I'm going to use one side. The answers will be what? Negative. Take note of the order. If I put 2 positive, I get positive. If I put 2 negative, I get positive. But here, if I alternate them, I get negative results. So that's the conclusion for multiplication. So let's quickly take division. And then I also want to. All right, so we go to division. Number 4, division. So in division, if I say positive divided by positive, this will be positive over positive, and that must be positive. So if I say 2 divided by, let's say 1, it will be 2 over 1, that is what? 2. Just use that as an example, just to give you a later feel of what we're doing. Therefore, B, if I say positive divided by negative, it will be positive, to mean positive over negative, which will be what? Negative. Another scenario is 2 divided by negative 1, which will be 2 over negative 1. And that will be what? Negative 2. Take note of something. The negative has a dominant effect also when it comes to dividing or division. Negative has a dominant effect when it comes to division. Right? So, irrespective of whether it's a numerator or denominator, negative divided by positive would imply negative over positive. And that will give me what? Negative. So if I have 2, negative 2 divided by 1, I'm going to have negative 2 over 1. That will be negative 2. Right. Now let's take another one. D. I have a negative divided by negative. Just like what happened in multiplication, when 2 negatives interface, a new entity is formed. That will be what? Positive. Right. So this will be negative over negative. And that will be what? Positive. So negative 2 divided by negative 2 equals to negative 2 over what? Negative 2. And that is what? 1. Right. Now, take note of this. One takeaway from here is that when we divide 2 numbers, one is a numerator and one is a denominator. When we divide 2 numbers, one essentially, the first number we write is the numerator, and the second number will write the denominator. So it is numerator over denominator. I really want you to take note of that because we'll go into something interesting much later when I come into the concept of fractions. I'm going to be changing your perception of fractions. So just it's a different take on mathematics, different take on mathematics. So you really need to keep your heart very open because I'm not going to follow conventional standards that you use. Right? It's very important to note that BODMAS does not apply only to directed numbers. It applies to a lot of areas in mathematics. Oh, I said I was going to give us something. I'm almost forgetting that. Now, we know that all numbers, all natural numbers are either odd or even. How do we know that? All natural numbers, or when we say natural numbers, we're talking about all whole numbers, are essentially what? Odd or what? Even. So there's also another knowledge you need to have when it comes to natural numbers or whole numbers, and that's something I don't want to leave without touching. Now let's watch this. So let's look at addition. If you have an odd number added to an odd number, what do you get? If you have an odd number added to an even number, what do you get? If you have an even number added to an even number, what do you get? And if you have added to an odd number, what do you get? And when you have an even number added to an even number, what do you get? You know, my years of teaching mathematics has taught me something. Your problem is not the problem of the new topic. Often another challenge is how well have we built your foundation, or have you built your foundation? Odd plus odd will give you what? I'll take a case. And to do this, all right, so let me allow you to put your answers. Put your own answers, let's see. Subtraction. Maybe I should give it to you in my next class. I will then look at it. And then explain to you why those answers are that. Try that out. Now let's go to multiplication. Even times even times odd times even, odd times odd. Let's also go to division. Even divided by even. Even divided by odd. Odd divided by even. And then odd divided by odd. I want you to try and answer all of these, and in my next meeting, I'll be able to shed more light on that. Some things you really need to be sure of. Now, by way of S4, where will this come relevant? There's an aspect of algebra we call rather quadratic or quadratics. If you're going to solve quadratic by method of factorization equation, where you're going to factorize the quadratic expression, if it's factorizable, you need this knowledge to be able to do that. So take this little thing I've done now very seriously, because you will need it a lot when we come to quadratics, expressions or equations.